It is perhaps the most intensely studied artifact in human history. A length of linen measuring 14.5 feet by nearly 4 that bears the faint, haunting image of a crucified man. For centuries, it has been venerated by millions as the sacred burial cloth of Jesus of Nazareth, a silent witness to a foundational moment of faith. Yet, since its first recorded appearance in the 14th century, the Shroud of Turin has existed in a crucible of controversy, a battleground between belief and empirical evidence. Now, a new arbiter has entered the fray: artificial intelligence. When the enigmatic face of the shroud was rendered into data and fed into the cold logic of machine learning, researchers expected clarity. Instead, the initial results seemed to deepen the mystery. The algorithms detected patterns and signals that were profoundly unsettling. Hidden structures within the weave of the fabric and radiation signatures that appeared to defy the known laws of physics. They suggested an image not painted, not scorched, not printed, but formed by an event beyond the scope of any known medieval technology. The specter of the carbon-14 dating tests still lingers, which placed the cloth firmly in the Middle Ages. Yet proponents counter with a persistent claim that the sample was taken from a later medieval repair, that the scientists had tested the wrong piece. But the digital inquest did not end there. In a recent meticulous study published in the academic journal Archaeometry, a different conclusion emerged. Brazilian three-dimensional designer Cicero Marais deployed a suite of sophisticated modeling software, Make-Human, Blender, and Cloud Compare, to simulate the precise way a fabric would drape over a form. Two scenarios were tested with exacting detail. The first, a fully three-dimensional human body. The second, a low-relief sculpture, a flat surface with shallow raised contours. The results were stark. The simulation involving a real human body produced distortions utterly inconsistent with the image seen on the shroud. However, when the virtual cloth was draped over the low-relief sculpture, the resulting image was a startling match. This offered a clear, technically grounded explanation for how the image may have been created: a deliberate, masterful work of medieval religious art. The findings challenge the long-held belief of its divine origin, yet they do not diminish its power. Whether a divine relic or a masterwork of human ingenuity, its power is undeniable. The shroud remains a profound paradox, an object that forces a radical re-evaluation of what we believe is possible. In its threads, we see not just the image of a man, but a reflection of our own enduring search for proof in a world of faith, and for meaning in an age of machines. In the year 1989, science seemed to deliver a final verdict on one of history's most enigmatic objects. Through the precise lens of radiocarbon dating, samples from the Shroud of Turin were tested. The results pointed not to the dawn of Christianity, but to a period between 1260 and 1390. The cloth, it appeared, was a product of the Middle Ages, a masterful and pious forgery. But the shroud is a master of ambiguity. Almost immediately, a counter-argument arose, a question that has lingered for decades. Was the tested sample truly representative of the whole? Critics suggested the fragment came from a section expertly repaired by medieval nuns, a patch of newer linen woven into the ancient fabric. And so, the debate, which seemed settled by atomic decay, was reignited, leaving the true age of the cloth unresolved, hanging in a delicate balance between scientific certainty and historical doubt. Decades later, in an age of digital phantoms and artificial intelligence, a new kind of inquiry began. Not with carbon atoms, but with code. In the virtual laboratory of researcher Thibaut Marais, the linen was resurrected. His simulations sought to answer a fundamental question. How was the image formed? Two distinct models were constructed. In the first, a virtual cloth was draped over the complex, three-dimensional form of a whole human body. As the digital fabric settled, it flowed over rounded limbs and contoured to the curves of a face, just as real linen would. The resulting image, however, was a failure. It appeared stretched, distorted, a grotesque caricature. This is a well-understood phenomenon in art and archaeology, known as the Agamemnon mask effect. When a two-dimensional surface is wrapped around a three-dimensional object, the features are pulled wide, the prop-on print that bore little resemblance to the serene, unnaturally flat image seen on the Shroud of Turin. Then, the second model was tested. This time, the cloth was placed not over a full body, but over a low-relief surface, a shallow, sculptural effigy. The outcome was startling. The two digital realities diverged profoundly. The imprint from the bas-relief closely matched the proportions, the clarity, and the haunting appearance of the actual shroud. The distortion vanished. The contours of the face and the outline of the body aligned with an uncanny fidelity. The digital evidence was compelling. The image on the shroud behaves not as if it wrapped a corpse, but as if it received an impression from a flattened, artistic surface. The study suggested a lost technique, a process of extraordinary skill. A master craftsman could have carved a shallow form from wood, stone, or even metal. Upon this mold, heat or pigment might have been selectively applied to the raised areas, allowing the image to transfer cleanly onto the fabric with minimal distortion. This method would elegantly explain why the shroud's image appears so uniform, so graphically precise, rather than warped and wrapped as one would expect from a true burial cloth. While the simulation could not entirely rule out an origin from a real body, the weight of the digital evidence leaned heavily toward an artistic explanation. Marais did not speculate on the exact materials used, but his conclusion was clear. The shroud is best understood as a funerary object, created with a level of technical sophistication that commands respect. This interpretation aligns perfectly with the known artistic practices of the medieval period. Low-relief depictions of religious figures were common across Europe, adorning tombs, memorials, and reliquaries. The shallow carving was a familiar and well-developed method, making the proposed process entirely consistent with the artistic knowledge of the time. Yet, just as one digital door seemed to close, others opened. Surprisingly, Marais' analysis was not the only study to apply artificial intelligence to the shroud that year. Several independent examinations deployed similar technologies, but their findings were far from definitive. Instead of providing clarity, these AI-based scans uncovered new layers of complexity, digital ghosts in the machine that defied simple explanation. They raised more questions than they answered, deepening the central mystery rather than resolving it. For centuries, the cloth has been subjected to the full arsenal of human inquiry, from the first microscopes to powerful X-rays, from carbon dating to artificial intelligence. Yet no single test has delivered a decisive truth. Each new technology, intended to be the final arbiter, has instead revealed another facet of its enduring enigma. Perhaps its true nature is not to be an answer, but a mirror, reflecting back the very questions of faith and doubt that we bring before it. A silent testament not to a single moment in history, but to our enduring search for the sublime. For centuries, it has rested in silence. A single 14-foot length of linen, bearing the faint, sepia-toned image of a crucified man. An object of veneration, of skepticism, of unending scientific inquiry. But now, a new kind of witness is being called upon to testify. An intelligence born not of faith or doubt, but of pure data. In the quiet hum of servers, artificial intelligence is offering a new way to see the ancient cloth, revealing a world of detail that has remained forever beyond the limits of human observation. The first of these digital revelations emerged when colossal, high-resolution scans, capturing every thread and fiber, were fed into advanced pattern recognition systems. These algorithms, designed to find order in chaos, began to analyze the very weave of the linen. And what they found was an order hidden in plain sight. Running through the fabric were ghostly parallel lines, structures of exceptional consistency, repeating at precise intervals. For generations, these markings had been dismissed as noise, the random decay of time, minor imperfections in a centuries-old textile. They were absorbed into the fabric's natural appearance, becoming part of its accepted story of age and wear. But the machine, devoid of assumption, classified them differently. It saw not random flaws, but an organized and repeating architecture, a structural signature embedded directly into the cloth. This discovery does not establish the shroud's authenticity, nor does it begin to explain the mechanics of its creation. Instead, it deepens the enigma. It reveals a level of complexity that is profoundly difficult to reconcile with any known artistic or manufacturing method. Even if the image were the work of a master forger, the precision implied by these underlying patterns would require a degree of control and technical foresight that exceeds what is known of both medieval craftsmanship and modern forgery techniques. Some researchers now dare to ask a more radical question. Could these structures function as a form of latent information, a message encoded into the very fabric of the mystery itself? While one form of artificial intelligence scours the cloth for hidden data, another is tasked with a more human endeavor, to give it a face. Generative networks, the same technology that creates digital art from simple text, have been trained on the shroud's faint features. From the ethereal, haunting impressions, these systems construct portraits of startling realism, giving the cloth a renewed and powerful visual presence across digital platforms. Whether they are forensic reconstructions or digital apparitions is a matter of intense debate. But their existence speaks to an ancient, unyielding human impulse, the need to see, to connect with the individual behind the icon. A second wave of analysis pushed this digital microscope further, turning its gaze from the weave of the linen to the landscape of the body image and the bloodstains. Deep learning models, trained to hunt for anomalies imperceptible to human observers, began to map the spectral data. They uncovered faint, directional streaks within the sepia tones, minute shifts in coloration that suggest a process of formation, not application. They catalogued thousands of variations in color intensity, too delicate and too numerous to be reliably identified by traditional methods alone. These details point not to a brush, a burn, or simple contact, but to a process far more intricate, one whose physics remain entirely unknown. Yet it was within the bloodstains, long confirmed to contain hemoglobin and other biological markers, that the most unsettling discovery was made. The algorithms detected a faint, almost a structure, seemingly imposed upon a liquid. It implies that the force which created the body image interacted with the blood's fluid components in a consistent, highly structured, and unusually precise manner. The interaction appears not chaotic, but exquisitely ordered. The machine offers no final verdict. It does not speak of miracles or forgeries. It simply presents a new layer of evidence, a complexity that defies simple explanation. The data points to a process of immense sophistication, one that seems as alien to a medieval artisan as it does to a modern scientist. In the end, artificial intelligence has not solved the riddle of the ancient linen. It has, instead, given its mystery a new and more profound dimension, reminding us that even in an age of absolute information, some questions are not meant to be answered, but to be deepened. In the quiet hum of a modern laboratory, a new kind of eye was turned upon an ancient enigma. Multispectral analysis, a technique that forces an object to surrender secrets hidden across wavelengths, deepened the puzzle. By evaluating ultraviolet, infrared, and visible light simultaneously, artificial intelligence began to chart a landscape invisible to human sight. It detected features not of pigment or dye, but of the linen's very substance. Across the cloth, the machine mind registered faint signals, subtle alterations in the cellulose fibers themselves. These were not random marks of age, but organized patterns that aligned with startling anatomical precision to the contours of the human figure. They spoke of things unseen on the surface, whispers of muscle tension, the precise positioning of limbs, the gentle topography of facial contours, all encoded in regions where the visible image had long since faded into ambiguity. Among the most profound and perplexing findings are those that lend credence to a radical hypothesis, a speculative idea often described as energy imprinting. This concept proposes that the image is not a substance added to the linen, but is instead a modification from within, a code written into the molecular architecture of the cloth. The artificial intelligence detected minute yet coherent variations in fiber orientation, in density, and in reflectivity. These patterns, stretching across broad sections of the textile, appeared to form an organized structure, a faint but persistent ghost supporting this extraordinary possibility. Yet, the data remains a whisper and the theory unproven. What then do these digital apparitions truly point to? If the patterns are genuine, were they formed by a deliberate and inexplicable design? Or are they merely phantoms of chance, intricate illusions born from centuries of random degradation? How could such precision exist on a textile woven in an age centuries before the dawn of modern technology? The genesis of this scientific odyssey began in the year 1898. In a darkroom in Turin, a photographer named Secondo Pia developed a plate that would transform an object of veneration into one of history's most scrutinized scientific artifacts. As the image of the shroud emerged from the chemical bath, Pia was met with a breathtaking shock. The negative plate revealed a positive im. From that moment, the shroud's history was irrevocably fractured. The controversy that had always shadowed its existence now ignited into a firestorm of scientific inquiry. The photograph was a threshold. Once crossed, there was no returning to simple faith or simple skepticism. Researchers from every discipline, chemistry, biology, medical forensics, optical image analysis, were drawn to the mystery. Over the ensuing decades, the scientific study of the shroud coalesced into three primary avenues of investigation: the analysis of its material composition, the biological and forensic examination of its markings, and the deconstruction of the image itself. The first direct formal inspection took place between 1969 and 1973, a cautious foray aimed primarily at assessing the cloth's preservation needs and determining which tests it could safely endure. This preliminary work led to the formation of an 11-member Turin Commission, a council tasked with advising on both conservation and the tantalizing prospect of future research. In 1973, 5 scientists from this commission were granted permission to conduct preliminary studies, analyzing small, carefully extracted samples to better understand the fabric's condition. Then, in 1976, the investigation took an extraordinary leap. The shroud was about to be examined through the lens of the space age. Physicists John P. Jackson and Eric Jumper, alongside photographer William Motton, applied image analysis techniques they had originally developed for aerospace research. The same digital tools designed to map the surfaces of distant planets were now turned upon this single piece of ancient linen. Building on their groundbreaking efforts, these 3 pioneers would soon join a team of more than 30 experts, each bringing the pinnacle of their field to bear on a mystery that only seemed to deepen with every answer it yielded. The cloth remains a mirror, reflecting not only the image it bears, but the very limits of our inquiry. With each technological advance, we see our own reflection more clearly, our insatiable drive to know, and the profound, humbling silence that greets our most persistent questions. In the year 1977, a team of distinguished scientists, drawn from disparate fields, united with a singular, audacious goal: to subject one of Christianity's most sacred relics to the unblinking eye of modern science. They called themselves the Shroud of Turin Research Project. STURP, as it would come to be known, was preparing to step across a threshold that had remained closed for centuries. By 1978, the Vatican had granted this assembly of physicists, chemists, and imaging specialists direct and unprecedented access to the cloth itself. The stage was set for a confrontation between ancient faith and empirical reason. But even as STURP prepared for this historic encounter, another breakthrough was unfolding in parallel. Working independently in Turin, the Italian scientist Giovanni Tamborelli harnessed the nascent power of digital image processing. He created a 3-dimensional rendering of the face on the shroud, with a resolution that surpassed all previous efforts. In a stroke of digital archaeology, Tamborelli electronically erased the dark stains of what appeared to be blood, allowing the serene, haunting facial image beneath to be seen with astonishing new clarity. Then, in October of that same year, the STURP team began its work in earnest. For 5 continuous days and nights, they subjected the linen to a battery of non-invasive tests. Their most crucial act was the collection of physical evidence. With meticulous care, they applied 32 strips of specially formulated adhesive tape to the surface of the relic, lifting microscopic samples for analysis. 18 of these samples were taken from the mysterious image areas, the faint sepia tones of the body and the stark crimson of the blood. 14 were control samples, lifted from the untouched linen between the images. These precious fragments were entrusted to Walter McCrone, a titan in the field of chemical microscopy. McCrone was a legend, a man whose word could authenticate a forgotten masterpiece or expose a clever fraud. In his Chicago laboratory, he subjected the samples to the rigors of polarized light microscopy, a technique that bathes microscopic particles in a dance of light, revealing their hidden chemical identities. His conclusion, when it came, was unequivocal and shattering. The body image, he declared, was not the result of some inexplicable supernatural event. It was a painting. Specifically, a delicate application of diluted red ochre pigment suspended in a collagen-based tempera binder, a method entirely consistent with the work of European artists from the 14th century. The blood, he further contended, was not blood at all, but a clever artistic enhancement using vermilion pigment to achieve a realistic effect. Their own analyses, spectroscopy, infrared thermography, X-ray fluorescence, yielded data that seemed to contradict Macron's findings. They argued that no known pigment could account for the image's unique, three-dimensional, and chemically superficial properties. The dissent was not merely academic, it was deeply felt. Mark Anderson, a specialist in Raman microscopy who had worked alongside Macron, found that the fibers from the blood. A chasm opened within the very heart of the project. The disagreements became irreconcilable. In June of 1980, Walter Macron, the eminent authenticator, resigned from Stirp, returning all the tape samples in his possession. The scientific schism was complete. Later examinations by other team members, John Heller and Alan Adler, seemed to deepen the mystery. They confirmed the presence of iron oxide, a key component of red ochre, but argued it was a red herring. The iron, they proposed, was a natural contaminant absorbed by the flax fibers during the retting process, where the plant is soaked in water for days. The exceptional chemical purity of the linen, when compared to other ancient textiles, suggested that this background iron could not be responsible for creating the detailed, high-resolution image. Macron, however, never wavered. Long after leaving the project, he became the most vocal and persistent proponent of the forgery theory. Through academic journals, public lectures, and a book published in 1996, he meticulously defended his position. The Shroud was a masterful medieval painting, and it contained no real blood. He argued that his former colleagues lacked the specialized expertise in the microanalysis of historical artworks, and that their failure to detect the pigments was simply a testament to the limitations of their instruments against a master forger's subtle technique. For his vast and varied contributions to the field of chemistry, Walter Macron received the American Chemical Society's National Award in Analytical Chemistry in the year 2000. Yet for all the accolades and all the certainty, the debate he ignited continues of science. The cloth remains, a silent testament not to a single answer, but to the enduring power of the question itself. It is an object that should not exist. For decades it has been subjected to the unblinking gaze of science, to countless laboratory experiments and the most advanced analytical tools of our age. Yet, no one has been able to reproduce its central, haunting feature under controlled conditions. The question echoes through the halls of academia, and the for its properties could even be understood. The Shroud of Turin. At its most fundamental, it is a simple piece of linen cloth, but upon its surface lies a mystery that deepens with every attempt to solve it. In 1978, a team of distinguished scientists known as the Shroud of Turin Research Project, or STIRP, was granted unprecedented access. After years of exhaustive testing, they reached a striking and, for many, an unsettling conclusion. They could not explain how this ancient linen came to bear the faint, ethereal image of a bearded man, his body marked with wounds perfectly consistent with a Roman crucifixion. That void, that absence of a clear scientific answer, became a crucible for decades of fierce debated that simple natural processes were responsible, a slow chemical reaction between the cloth and the body it once wrapped. Others pointed to the forgotten technical genius of a medieval artisan, a master forger of holy relics. And still others suggested the image was the byproduct of an extraordinary physical event, a burst of energy intimately connected to the Christian narrative of the resurrection. Each theory was offered with confidence, yet none has ever succeeded in settling the question. The most common and perhaps most rational claim is that the image is a painting, the work of a human hand. If this were true, the answer would lie in chemistry. A detailed analysis should reveal the telltale signatures of pigment or dye, the very same materials found in the study of any other historic painting. The Stirp researchers, however, brought the full force of modern science to bear on the cloth and found no such evidence. There were no pigments, no dyes, in sufficient quantity to form the image. Under the microscope, there was no trace of brushstrokes, no directionality, no hint of an artist's application. The image itself is a phantom. To the naked eye, it is almost invisible, a subtle discoloration that resolves into a human form only from a distance. Further analysis revealed its most perplexing quality. The color does not come from any substance applied to the surface, nor from any material absorbed into the weave. Instead, the very flax fibers of the linen are themselves discolored, a subtle chromic alteration of the cellulose. This change is impossibly thin, penetrating only the topmost fibrils to a depth of leached or altered by standard chemical treatments. Based on these astonishing findings, the Stirp team was forced to conclude that the image of the scourged and crucified man was not the work of an artist. The cloth bears other, more visceral marks, genuine bloodstains, later identified as type AB. These stains contain traces of human DNA, though the genetic material is now badly degraded by time. A dissenting voice, that of microscopist Walter McCrone, argued that these red stains were not blood at all, but microscopic particles of iron oxide, a pigment commonly known as red ochre. For a time, his conclusion fueled the forgery theory, but it was sharply disputed by other forensic experts and is now largely rejected by the broader scientific community that has studied the shroud. Other proposals have suggested mechanical means of creation, that the image resulted from rubbing the cloth over a heated bas-relief sculpture or from scorching it against such a surface. Yet the image's unique physical and chemical properties, its perfect superficiality, and its three-dimensional information content do not support either idea. And so the inquiry turns inward, to the very structure of the linen. The central line of investigation now focuses on natural chemical reactions. Since the image is nothing more than darkened cellulose fibers, researchers are no longer asking who might have caused the change, but what could have. It remains a question not of faith, but of physics and chemistry, a silent testament to an event that lies just beyond the horizon of our comprehension. In the quiet halls of science, the most profound mysteries are often met not with grand pronouncements, but with careful, measured hypotheses. In the year 2002, Raymond Rogers of the Los Alamos National Laboratory offered one such proposition. He turned away from cataclysmic events and looked instead to the subtle power of gentle warmth. He theorized that the image on the shroud was not a scorch from a burst of supernatural energy, but a delicate chemical browning, a reaction that could be triggered by temperatures as low as 40 degrees Celsius. Such a thermal signature, he noted, could be produced by the human body itself in its final, desperate moments, a feverish peak brought on by dehydration or extreme physical trauma. The theory was elegant, grounded in known chemistry, and required no leap into the extraordinary. Yet it rests on an unsubstantiated premise. There is little to no evidence that burial cloths, under any known natural conditions, develop such incredibly detailed, high-resolution images from residual body heat alone. If not from an external heat, perhaps the reaction was ignited from within, by the very chemistry of death. Other researchers have long suspected that compounds released by the body itself may have been the true catalyst. Early in the 20th century, the French biologist Paul Vignon championed the idea of a vaporograph, proposing that ammonia, released from the breakdown of urea in sweat and bodily fluids, reacted with the burial spices on the cloth to form the image. But this mechanism presents a fundamental problem of resolution. A cloud of ammonia vapor would create a hazy, indistinct miasma, a blurred ghost. It could not account for the hauntingly precise figure seen on the linen, the sharp lines of the face, the distinct wounds, the individual strands of hair. Decades later, in 1982, biophysicist John DeSalvo offered a different agent: lactic acid, another component of human sweat. He drew a compelling parallel to a curious natural phenomenon known as vulcae onto the paper, leaving a dark, spectral negative of itself. DeSalvo argued that lactic acid could have reacted with the fibers of the shroud over time. It was an intriguing comparison, suggesting a slow, organic imprinting process, a chemical whisper left behind by direct contact. But another theory, more radical and enduring, treats the shroud not as a chemical stain, but as a photograph. The revelation that the image behaves as a photographic negative, a discovery that stunned the world, only served to deepen its enigma. The man who first captured this quality, Secundo Pia, briefly entertained the notion himself, wondering if some primitive photographic process could be the answer. This seed of an idea was later cultivated by the South African art historian Nicholas Allen. He argued that the creation of such an image was, in principle, within the grasp of a medieval scholar. The proposed method is a masterclass in medieval ingenuity. A linen cloth, carefully treated with a solution of silver nitrate, is stretched taut within the deep black of a camera obscura. According to Allen's research, the light-sensitive properties of silver nitrate were not a modern discovery. The compound, which darkens to metallic silver upon exposure to light, was known to the great minds of the past. It was described by the 8th century Arab alchemist Jabir ibn Hayyan, and later by the 13th century polymath Albertus Magnus. Allen proposed that a forger could have projected an image of a sculpted body onto the sensitized cloth using a simple quartz lens. The choice of quartz chemical reaction in the silver nitrate. Using precisely this technique, Allen succeeded in producing his own. And yet, for all its brilliance, the photographic theory casts its own long shadows of doubt. It fails to adequately explain how the image would be permanently fixed to the cloth once the unexposed silver nitrate was washed away. More critically, it requires us to believe that medieval artisans mastered advanced concepts in optics and photochemistry, only to leave behind not a single text, not one diagram, not a whisper of this revolutionary technology in the entire historical record. It would amount to a conspiracy of silence across centuries of scholarship. Questions also persist about whether such a process could truly replicate the unique three-dimensional information encoded in the shroud's varying image intensity. For most, Allen's work stands as a monumental feat of reverse engineering, an impressive demonstration of what is possible rather than a convincing explanation of what actually occurred. Each thread of inquiry, when pulled, seems to unravel. The simple heat, the reactive vapors, the captured light, all offer a glimpse of a plausible mechanism, yet none can fully capture the artifact in its totality. The image remains suspended between faith and forensics, challenging the very limits of our investigation. It exists as a silent testament, not to a single verifiable event, but to the enduring power of a question that science, for all its tools and all its rigor, has yet to answer. Beyond the theories of paint and pigment, of scorch and stain, lies a more profound, more unsettling proposition. That the image on the Shroud of Turin was not made, but created by a release of energy. It is a hypothesis that pushes at the very boundaries of known physics, suggesting an event for which we have no modern parallel. An international consortium, the Yahoo Shroud Science Group, has long contended that explanations tied to the supernatural, specifically the resurrection, cannot be summarily dismissed on scientific grounds alone. They argue from a position of epistemic humility, suggesting that if an unprecedented event occurred, it would necessarily produce unprecedented physical evidence. Within this framework, they explore posse, or perhaps surface electrical discharges, a form of corona effect, triggered by an unimaginably intense electric field enveloping the corpse. These proposals inhabit a liminal space between physics and metaphysics. They depend on processes for which we have no established equations, no observable analogues. Because they presuppose an event that transcends ordinary physical laws, science, by its very definition, lacks the tools to either verify or falsify them. They are, in the strictest sense, untestable. Yet that fundamental uncertainty has not deterred all inquiry. Julio Font, a chemist at the University of Padua in Italy, has dedicated years to a theory that attempts to bridge this gap. He proposes that the image was formed in a fraction of a second when a sudden, powerful burst of radiant energy acted upon only the most superficial fibers of the linen, leaving the cloth beneath untouched. To visualize this, he suggests an analogy: a linen cloth draped over a conductive sphere. A brief touch from an electrode, a flicker of corona discharge, and an image is seared onto the surface with microscopic precision. Fonte speculates this energy could have manifested in numerous forms: a flood of intense visible light, a wave of ultraviolet radiation, a pulse of X-rays, or even streams of subatomic particles radiating directly from the body. In a bold interpretive leap, he draws a parallel to a biblical account, the Transfiguration, where Christ's appearance and clothing are described as becoming supernaturally, brilliantly bright. While this connection is theological, not empirical, Fonte argues that the underlying premise is testable. Modern science, he insists, can and should investigate whether such forms of radiation are capable of producing a comparable, high-resolution, and supremely shallow image on ancient linen. This entire line of reasoning, however, met with formidable skepit. Shroud of Turin research project, Rogers argued that many of these radiation-based explanations verge on pseudoscience. He saw in them a troubling pattern. They were constructed not only to explain the mysterious image, but also to conveniently provide a mechanism that could have altered the cloth's carbon isotopes, thereby invalidating the radiocarbon dating results that placed the shroud in the 14th century. In his view, these theories were a textbook case of starting with a desired conclusion, that the shroud is the authentic burial cloth of Christ, and then working backward to invent a physical process to justify that belief. For Rogers, true science allows the evidence to lead the way, no matter how uncomfortable the destination. More than a decade after he voiced these powerful objections, the debate remains fundamentally unchanged. The shroud continues to defy any single, universally accepted explanation, a silent testament to a persistent and polarizing mystery. As the theoretical arguments reached an impasse, some researchers turned away from the laboratory and the microscope, seeking answers not in abstract models, but in the stark and brutal reality of physical recreation. Their experiments would only deepen the enigma. In the year 1929, long before the advent of carbon dating, a group of researchers undertook a study of breathtaking and controversial audacity. To test the authenticity of the bloodstains on the shroud, they sought to replicate their source. They strapped living human volunteers to a full-size, historically accurate cross. In a scene that seems torn from a bygone era, they then covered the subjects in blood, meticulously observing how it would flow from wounds, how it would pool and clot, and how it would transfer to a linen sheet. While the scientific establishment of the day was already leaning toward the shroud being a masterful medieval creation, this team was determined to use direct, visceral experimentation to see if the grim cartography of crucifixion mapped onto the stains seen on the ancient cloth. From bursts of imagined light to the tangible suffering of volunteers, every attempt to solve the riddle of the shroud seems to lead not to clarity, but to more profound questions. The cloth refuses to yield its secrets. It remains a canvas onto which we project our greatest hopes and our most rigorous doubts. A mirror reflecting the inherent tension between what can be measured and what must be believed. It endures not as an answer, but as the ultimate question, wrapped in linen. In a controlled laboratory setting, a human subject is prepared. Volunteers, chosen with anthropological precision, are selected to match the haunting body proportions seen in the front and back images of a linen cloth that has baffled the world for centuries. This is not an act of devotion, but a rigorous scientific inquiry. Special attachments, carefully engineered for wrist and foot, allow them to be suspended, realistically, upon a cross. The entire apparatus can be adjusted, tilted by degrees, to achieve a precise alignment with the posture suggested by the ancient fabric. Overseeing every stage are medical personnel. Their purpose is twofold: to ensure the absolute safety of the participants and to monitor and record the results with clinical detachment. Blood, drawn and stored, is then applied systematically to the body. As it courses downwards, its flow patterns, dictated by gravity, skin texture, and the contortions of the human form under stress, are meticulously documented. Every rivulet, every stain, is photographed and compared with the silent, sepia-toned testimony of the Shroud of Turin. This modern ordeal was designed to challenge a century of forensic debate. As far back as 1919, earlier analyses had argued that the bloodstains on the shroud were fundamentally flawed, reflecting an anatomically impossible posture. They proposed that its creator, working from imagination rather than reality, had depicted a victim with arms crossed bizarrely above their head, an arrangement historically and physically disputed. This new, hands-on reconstruction of crucifixion mechanics sought to test those claims, to see if the marks on the linen could, in fact, be reconciled with a body in the throes of death. And yet, for all its meticulous detail, this modern reconstruction exists in the shadow of a formidable scientific consensus. Historical accounts and, most critically, radiocarbon dating consistently point to a single, inconvenient truth: a 14th century creation. As forensic scientist Matteo Borini, himself involved in earlier critiques of the shroud's authenticity, has emphasized, faith and scientific evidence occupy distinct spheres. Personal belief may guide one's interpretation, but the physical reality of the shroud must be judged through repeatable experimentation and cold, hard data. This experiment is but one chapter in a long and often unconventional history of subjecting the linen to the crucible of science. John Jackson, a physicist who was a key participant in the major 1978 scientific examination, later proposed a startling hypothesis. He theorized that the image might have been created by a burst of radiation emanating from a body that was, in his words, dematerializing. Other researchers have painstakingly analyzed the remnants from that landmark study. Microscopic pollen grains used to trace the cloth's possible journey across continents, and the telltale stresses recorded in its delicate, recovered fibers. Some tests have been particularly striking in their ambition. In 2015, Giulio Fanti of the University of Padova attempted to replicate Jackson's radiation hypothesis. He wrapped a mannequin in linen and subjected it to a staggering 300,000-volt electrical discharge. For 24 hours, the air around the cloth was ionized, charged, and alive. The process produced visible markings, a faint scorch on the fabric. But it did not provide a definitive explanation. It was another ghost in the machine, another tantalizing clue that led nowhere. Despite decades of such relentless experimentation, no consistent physical mechanism has yet been found to fully account for the image's formation. Ultimately, the most enduring mystery of the shroud lies not in its image, but in its age. In 1988, the question was submitted to the unblinking eye of atomic science. Independent radiocarbon dating tests were carried out at 3 separate, prestigious laboratories. The samples were prepared, the atoms counted, the half-lives calculated. The verdict, when it came, was clear and unambiguous. The linen cloth, which for so long had been revered as a sacred relic, was declared a product of the Middle Ages. But even this definitive judgment has not silenced the debate. For some, it was the final word. For others, it was merely the beginning of a new set of questions about contamination, sample integrity, and the limits of the test itself. The shroud remains an object that exists at the very edge of our understanding, a canvas upon which we project our deepest convictions and our most profound doubts. It refuses to yield its final secret, forcing each generation to confront the fragile boundary between what can be measured and what must simply be believed. For centuries, it had been an object of veneration, a silent witness wrapped in mystery. But in the late 20th century, faith would be met by the unblinking gaze of empirical science. 3 of the world's most respected radiocarbon dating laboratories, the University of Oxford, the University of Arizona, and the Swiss Federal Institute of Technology, were chosen for a task of unprecedented historical ant, was meticulously excised from a corner of the Shroud of Turin. The samples were prepared, analyzed, and the results collated. The verdict, delivered with a statistical confidence of 95%, was unambiguous. The linen dated to a period between 1260 and 1390. This time frame was not arbitrary. It aligned almost perfectly with the shroud's first documented appearance in church records in medieval France. The scientific dating placed the cloth slightly later than some art historical estimates, which had proposed it might be an 11th century icon, a painted or stained textile created for liturgical ceremony. For a moment, it seemed the mystery had been solved. The shroud was a masterpiece of medieval artistry, not a relic from antiquity. Yet for proponents of the shroud's authenticity, the verdict was not an end, but a new beginning. They challenged the radiocarbon results, proposing a compelling alternative: that the tested fragment was not from the original cloth at all, but was part of a medieval repair, a patch skillfully woven into the fabric by nuns to mend damage from a fire. Other explanations were put forward, suggesting the sample had been contaminated by biological materials over the centuries, or that exposure to carbon monoxide from a past blaze had skewed the carbon isotope ratio. Each of these hypotheses, however, was systematically examined by the scientific community and, one by one, refuted, leaving the original medieval dating seemingly intact. But the book on the carbon dating was not entirely closed. In recent years, statisticians have returned to the raw data from 1988, scrutinizing the numbers with new analytical tools. They were searching for a subtle discord, a statistical ghost in the machine. These studies found evidence of what they termed inhomogeneity, a lack of complete consistency across the results from the three laboratories. The discrepancy could stem from unidentified variations in the fabric samples themselves, or perhaps from subtle differences in the meticulous cleaning procedures each lab employed before testing. A 2020 analysis suggested that a minor adjustment of just 10 years to the results from two of the labs would reconcile the data, while an 88-year correction could align all three results into statistical harmony. The medieval date still held, but the absolute certainty had been fractured by a sliver of doubt. While the debate over its age simmered, other disciplines turned their lenses upon the shroud's most enigmatic feature: the image itself. In 2011, researchers applied modern digital analysis to two historic photographs of the cloth, including a 1931 reproduction of Giuseppe Enri's haunting photographic negative. The detailed processing revealed no hidden layers, no secret images of flowers, coins, or other objects that some had claimed were faintly visible. The image was exactly what it appeared to be, with no evidence of an artist's hidden signature. But perhaps the most profound story was not written in carbon atoms or pixels, but in the microscopic dust of ages. In 2015, Italian scientists studied human and non-human DNA collected from the shroud and its backing cloth during vacuuming sessions in 1977 and 1988. The findings painted a portrait of a truly global artifact. They identified traces of 19 distinct plant taxa, a botanical map stretching from the heart of the Mediterranean to Central Europe, from North Africa to the Middle East, and to the distant reaches of Eastern Asia and even the Americas. And woven into this tapestry of pollen and dust was the story of humanity itself. Human mitochondrial DNA sequences traced a lineage of contact, revealing that peoples from diverse populations across Europe, Africa, the Middle East, and as far as India had touched the shroud, or been in its presence. Even the unexpected made an appearance: the DNA of birds, and, remarkably, a marine worm native to the northern Pacific Ocean near Canada, an echo of a journey unknown. The sequencing of this genetic dust confirmed what history had long suggested, that for centuries, people from countless regions had come into contact with this cloth, leaving behind an invisible chronicle of their passage. While this globe-spanning diversity does not rule out a medieval European origin, it is equally compatible with a far more ancient journey, one that might have carried the cloth from the Near East across the known world. Science, in its quest for a single answer, had instead uncovered 1,000 stories. The shroud remains a paradox, an object whose physical age is contested, yet whose history is now proven to be deeply and profoundly human. Its threads hold not a simple truth, but the complex, layered story of a world that has reached out to touch it, leaving behind a chronicle of its own enduring quest for meaning. The very threads of the cloth whisper a story of distant origins, raising the unsettling possibility of Indian linen manufacture, an echo from a world far removed from first-century Judea. But embedded within these ancient fibers, a microscopic world holds its own testimony. Palynology, the study of pollen grains, offers a forensic lens into the shroud's journey through time and geography. In 1960, the Italian palynologist Marzia Boi proposed a compelling theory. She argued that the most abundant pollen found on the linen belonged to the genus Helichrysum, a flower whose oils were commonly used in the balms and ointments of ancient burial rituals. For a time, this seemed to be a powerful link to the past, a botanical ghost of a sacred anointing. But the microscopic story did not end there. A more recent, more precise analysis would challenge this initial finding, identifying the dominant pollen as Gundelia tournefortii, a thorny plant native to the Near East, but one whose presence tells a more ambiguous story than that of burial rites. From the infinitesimal to the whole, the anatomical consistency of the image itself has been a battlefield of scientific opinion for over a century. The examination began in earnest with the French anatomist Yves Delage in 1902. Delage, a man of science and a professed agnostic, stunned his contemporaries by declaring the image to be anatomically flawless, a perfect negative impression of a crucified man. Yet, where Delage saw perfection, later researchers have found profound inconsistencies. The serene, haunting figure on the cloth has been measured, analyzed, and compared against the brutal reality of its supposed ordeal. Archaeological discoveries provide a grim point of comparison. The study of a Roman crucifixion victim found near Venice in 2007 reveals a starkly different trauma. The heel wounds on that skeleton do not match the markings on the shroud, and crucially, no study of any crucifixion victim to date has shown evidence of nails driven through the wrists, a detail central to the shroud's iconography. Critics have meticulously catalogued further anomalies. Joe Nickel in 1938, and more recently, Gregory S. Paul in 2010, argued that the shroud's proportions defy reality. According to Paul's meticulous analysis, the face is too narrow and small for the head. The arms are unnaturally elongated and of uneven length, and the overall posture is physically improbable for a body in repose, let alone one that has suffered such trauma. The depiction of the hands, carefully arranged to cover the genitals, is particularly telling. This posture would have required a deliberate, artistic elongation of the right arm and hand, a conscious adjustment for modesty rather than a faithful, spontaneous imprint of a corpse. The bloodstain analysis has added another layer of intense scrutiny. In 2018, experimental studies sought to replicate the patterns seen on the linen. By comparing the fluid dynamics of blood flow from actual wounds with the marks on the shroud, researchers uncovered glaring inconsistencies. The rivulets of blood on the forearms and the backs of the hands appear disconnected, suggesting they would have required separate episodes of bleeding from a body in different positions. Similarly, the blood patterns on the front of the body do not align with those on the lumbar area, even when accounting for multiple bleeding events. The evidence points not to a single catastrophic event, but to a carefully composed image, an artistic or instructional creation designed to evoke the passion story. But perhaps the most compelling voice of doubt is not modern. It is not born of carbon dating or forensic modeling, but from the quill of a 14th century philosopher. On September 20th, 2024, historians announced a remarkable discovery. The earliest known record suggesting the Shroud of Turin was a deliberate fabrication has been found in a text far older than previously recognized. The French philosopher Nicole Oresme, a towering intellect of the late Middle Ages, celebrated for his meticulous scholarship and critical thinking, may have been among the very first skeptics. Around the year 1370, Oresme wrote Insight appears in his Problemata, a collection of writings composed between 1355 and 1388, only recently examined by the historian Nicolas Sarzeau at the Catholic University of Louvain in Belgium. Oresme's skepticism, written in the very era of the Shroud's first public appearance, is a historical bombshell. It suggests that from its very beginning, the object was viewed by thoughtful minds not with unquestioning reverence, but with reasoned suspicion. The layers of evidence, botanical, anatomical, forensic, and now historical, converge toward a single, disquieting conclusion. The image may not be a miraculous artifact, but a masterful one, a testament to human artistry and the profound, enduring need for faith to be made visible. It forces us to ask a deeper question. Is the things inspired a mirror reflecting not what was, but what we so desperately need to believe? Within the fragile pages of an unpublished treatise, a passage, long dormant, revealed itself. To the scholar who found it, a man named Sarzeau, its significance was immediate and profound. It was a voice from a deeper past, speaking with a clarity that threatened to rewrite a centuries-old story. The voice belonged to Nicole Oresme, a formidable 14th century thinker whose intellect was a scalpel, dissecting the world around him with deliberate, methodical precision. He did not merely accept, he interrogated. Oresme approached the towering edifice of religious claims with a critical eye, questioning the very architecture of belief. Why, he wondered, do people so readily accept certain phenomena as divine truth? His reflections were not the product of casual doubt, but of a rigorous and reasoned analysis, a philosophical inquiry into the mechanics of faith and credulity. Until this discovery, the historical record of skepticism surrounding the Shroud of Turin began much later. The narrative was anchored in documents from the years 1389 to 1390. Chief among them was a letter from Pierre d'Arcy, the Bishop of Troyes, who leveled a damning accusation. The shroud was a counterfeit, a clever deception cunningly painted by a known artist. But Oresme's critique shatters this timeline. His words, penned nearly 2 decades before the bishop's, offer an unprecedented glimpse into the earliest whispers of disbelief. He cautioned against the unthinking acceptance of the miraculous, urging scrutiny and reason. And as a prime example of a claim demanding such skepticism, he cited a manifest experience in a church in the region of Champagne, where it was claimed the authentic burial cloth of Christ was kept. To understand the weight of his observation, one must return to the world in which the shroud first appeared. Around the year 1355, in a small church in Lire, France, a length of linen was put on display. On its surface was a haunting impression: the faint, full-length image of a naked man, his hair long, his face bearded. Across the cloth were reddish-brown marks, arranged in a pattern that chillingly resembled the wounds of a crucifixion. The artifact sparked immediate and fervent fascinators, and that it was now performing miracles. Pilgrims flocked to see it, but as devotion grew, so did official scrutiny. Henri de Poitiers, then the Bishop of Troyes, investigated the relic and reportedly denounced it as a fraud, claiming to have confronted the artist who had created it. Decades later, his successor, Pierre d'Arcy, would repeat the accusation with even greater force. The controversy reached the highest echelons of the Church, where the Pope himself intervened, delivering a careful compromise. The shroud could remain on display, but it was to be presented only as a symbolic representation, an icon of Christ's burial cloth, not the genuine article. For its enduring power, it ultimately arrived in Turin in 1578, where it remains today, housed in the Cathedral of St. John the Baptist. Modern scholarship has brought new tools to bear on this ancient question. Andrea Niccolotti, a professor of Christian history at the University of Turin, highlights the fabric itself. Its complex herringbone weave, he notes, points to Loal, European origin. And yet, the image continues to defy simple explanation. Professor Niccolotti himself concedes its perplexing nature. The depiction is ethereal, possessing a detail and subtlety that cannot be easily explained by simple human contact or the crude painting techniques of the era. The argument settles upon a stark dichotomy. Only two possibilities seem to remain plausible. The image is either a genuine miracle, a supernatural imprint left by a divine event, or it is a work of profound and deliberate artistry. While for many of the Christian faithful, the miraculous explanation remains an article of faith, the weight of historical analysis, now bolstered by Oresme's early skepticism, makes the artistic explanation far more convincing. Oresme's 14th century warning echoes through the ages. He spoke of the all-too-human motives that can lie behind alleged miracles, noting that clergy might exploit venerated relics to solicit donations from the devout. His words are a powerful reminder that medieval observers were not a monolith of blind faith. They were capable of sharp discernment, recognizing the potential for deception, even in the most revered and sacred of objects. The shroud, then, is more than a relic. It is a battleground, where faith and reason have clashed for over 600 years. It stands as a silent testament not only to an enduring mystery of faith, but to the timeless, critical impulse of the human mind. An impulse that demands evidence, questions authority, and dares to seek truth, even when that truth challenges our most cherished beliefs. In the long and shadowed history of the Shroud of Turin, the narrative has often been framed by modern science and medieval politics. Debates have raged, anchored by the carbon-14 tests of the 20th century and the damning accusations of a 14th century bishop. But now, the discovery of a lost critique by the scholar Oresim forces a radical re-evaluation. It reveals that the first whispers of doubt were not uttered centuries later, but arose almost at the moment the cloth was first presented to the faithful. This early skepticism, a voice of reason from the Shroud's own era, predates the formal ecclesiastical disputes and the cold analysis of future laboratories. It demonstrates that this revered and provocative artifact was never an object of unquestioning belief. From its very inception, it was born into a world of controversy, a flashpoint for the collision of faith and doubt, destined to be contested for all time.